93 million miles from where we're standing, there's a planet close enough to the sun to melt lead by day, and cold enough to freeze it by night. It has no clouds, no wind, no sound, nothing to soften the sunlight, and nothing to hold the heat once darkness falls. This is Mercury, and it's the only planet in our solar system with almost no atmosphere at all. But what if that changed? What if Mercury woke up tomorrow wrapped in an atmosphere as thick and stable as Earth's? Would this scorched, cratered world suddenly become livable, or would being this close to the sun make an atmosphere even more dangerous than having none at all? To understand what would happen, we first need to understand why Mercury lost the fight for an atmosphere in the first place. Every planet close to a star gets bombarded by solar wind, a constant stream of charged particles blasting outward from the sun. Earth survives this because our planet has a strong magnetic field, generated deep inside a molten iron core, that deflects most of that radiation harmlessly around us. Mercury has a magnetic field too, but it's incredibly weak, roughly 1% the strength of Earth's. That's simply not enough to hold a real atmosphere in place. Whatever thin traces of gas Mercury does have get stripped away and blasted into space almost as fast as they could ever build up. So let's change the variable. Let's give Mercury a magnetic field as strong as Earth's, thick enough to actually hold a real atmosphere in place. What would that atmosphere have to deal with, being this close to the sun? The first problem is heat. Mercury already reaches surface temperatures over 800 degrees Fahrenheit during the day. Add a thick atmosphere, and you don't cool the planet down, you trap that heat in, the same way a greenhouse gas atmosphere traps heat on Venus. In fact, this is exactly why Venus, despite being farther from the sun than Mercury, is actually the hottest planet in our solar system. Its thick atmosphere holds in heat so effectively that surface temperatures stay brutally high day and night, everywhere on the planet. Give Mercury a similar atmosphere, and the same fate likely awaits it. Instead of becoming livable, Mercury could become even more hostile than it already is, a slow-cooking greenhouse world locked in permanent, inescapable heat. But there's a second problem, unique to Mercury specifically. Unlike Earth, which spins on its axis once every 24 hours, Mercury rotates incredibly slowly, completing one full day every 59 Earth days. That means one side of Mercury could face the sun for weeks at a time, absorbing endless direct heat, while the other side sits in prolonged darkness, losing whatever warmth it has out into space. A real atmosphere might try to even this out, carrying heat from the scorched day side toward the freezing night side. But the difference in temperature between Mercury's two extremes is so severe that even a full atmosphere might struggle to keep up, creating violent, planet-wide winds as heat tries to move from one side to the other. So would an atmosphere actually help Mercury, or would it make things worse? Based on what we know from Venus, a thick atmosphere so close to the sun almost certainly leads to a runaway greenhouse effect rather than a livable climate. Mercury wouldn't become a second Earth. It would more likely become a second Venus, just with even more extreme day-night temperature swings driving ferocious atmospheric winds across its surface. There is one narrow possibility worth considering. If Mercury's hypothetical atmosphere were thin enough to move heat around without trapping too much of it, and if its magnetic field were strong enough to block solar radiation without needing to be overly thick, there might be a small window where conditions improve rather than worsen. But that's a delicate balance, one that real planets rarely land on by accident. Earth managed it. Venus didn't. And Mercury, sitting even closer to the sun than either of them, would have the hardest task of all. In the end, Mercury's lack of atmosphere isn't just bad luck. It might actually be protecting the planet from becoming something far worse than the barren, cratered world we already know. Sometimes what a planet doesn't have says just as much as what it does.